We're going to be looking at the square root parent function. So whenever we see the square root, we know that this is going to be our starting point. So let's first come up with our points. So if our x value is 0, the square root of 0 is 0. If our x value is 1, the square root of 1 gives us 1. Now we're actually not going to go to 2 because you can't find the square root of 2. It's going to be an irrational number. So we're going to go straight to 4 because the square root of 4 gives us 2. And then we're also going to go to 9 because the square root of 9 gives us 3. So that way we have nice even numbers. We only want to use integers, whole numbers, not decimals for our parent function. So now we're going to graph this. 0, 0, 1, 1, 4, 2, 9, 3, and connect these points, and this is our parent function for the square root function. Draw an arrow because it does keep on going. For example, our next point could have been 16, 4, but we're just not going to draw it because it's off our graph. Looking at this, let's find our domain and range. So our domain, which is our x values, if we look at our x's, the leftmost point here starts at 0. It is a closed circle, so bracket. And then the arrow means that we keep on going to the right, so it's going to go all the way to infinity. So we're going to use a parentheses because it's infinity. For our range, now we're looking at our y-axis. So the lowest point, the bottommost point, is still this point. So we're still starting at 0. Again, bracket because it's a closed point. And then if we're going up, again, the arrow keeps on going up. We're going in this direction, but it's going to continue going up. So again, this is going to be infinity. So here's our domain and range. Some characteristics of this function. It is 1-to-1, which if you remember means it passes both the horizontal and the vertical line test. So either way, it's only going to touch the graph at one point if you draw any vertical or horizontal line. This function is increasing the entire time. So it's increasing from 0 to infinity, which is its entire domain. It's always increasing. It's never decreasing. And then the 0 here is 0, 0, because that's where it crosses the x-axis. Okay, so what we're going to be doing today is graphing transformations, and then also going from the graph back to the equation. So let's take a look at number 1. So just like before, we're going to start off by describing the transformations. So the thing that distinguishes this between our quadratics is now we have this square root instead of the squared. So this is what tells us we're starting off with this parent function right here. So from the beginning, I already know that my parent function is going to be these 4 points. So I'm going to start off by graphing it on this graph. So 0, 0, 1, 1, 4, 2, 9, 3. And again, I draw little x's, so I know that this is my parent function. That's what I'm starting off with. Okay, let's look at what the transformations are here. This -5 inside of your function, so it's inside the square root, means it's inside the function. It means that you are affecting the x values. And so if it's affecting the x, it's going to be shifting either left or right. Because it's -5, it's going to be going to the right because it's the inverse. Whenever we're talking about our x's, it's the inverse. The +3 is outside. So I'm going to write so that we added 5 to our x's, so write 5. This +3 is affecting our y's, which means that we're moving up 3. So we don't have any stretches or reflections, so all we're doing is taking all of these points and moving them right 5 and up 3. So let's start off with our 0, 0, right 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. There's our new point. Let's take 1, 1, and now I'm moving it right 5. 1, 2, 3, 4, 5, up 3, 1, 2, 3. Draw another point. The next point, so I'm taking 4, 2, moving it right 5. 1, 2, 3, 4, 5, up 3, 2, 3. And this one, if I move this one, it's going to go off the graph, so I don't need to worry about this. So let me just connect these 3. Draw an arrow because I know it keeps on going. And this is my f of x. That's my transform function. So again, we have to find the domain and the range. So we're looking at this function right here. If we look at the x's, this is the starting point, my leftmost point of my x's, which starts at x is equal to 5. So it's starting at 5, bracket, keeps on going to the right forever because of that arrow, so infinity, that's my domain. Range, same idea, but now we're looking at our y's. My lowest point is again this same point, but on my y-axis, this is equal to 3. So it's starting at 3, and again it keeps on going up forever. My highest point just keeps on going to infinity, so I'm going to have infinity as well for my range. So this is my answer for number 1. Let's look at number 2. So number 2 is a little bit different now. So again, the square root tells me that I'm starting off with 0, 0, 1, 1, 4, 2, 9, 3. So this is my original function, my parent function. This is what I'm going to be transforming. Now we have to look at what those transformations actually are. So this 2 is outside the square root. It's outside the function, so it's affecting your y value. Because it's affecting your y, it's not the inverse. It's only the inverse when it's affecting your x. So if you're multiplying your 2 by y, this is a vertical, because your y is going up or down, which is vertical. Stretch, because it is being multiplied by 2. So vertical stretch by 2. And now this negative is on the inside. So if it's on the inside, it's going to be affecting your x values. And if your x is changing signs, this is a reflection across the y-axis. So remember, if your x changes signs, it's a reflection across your y. If your y changes signs, it's a reflection across your x. So these are the two things that are happening here. Okay, so let's start off by reflecting this across our y-axis. So our y-axis is this one right here. So if we're reflecting it across our y-axis, we are moving all these points, so 0, 0 still stays here. I'm going to be reflecting it across the y-axis, so it's going to end up on the other side of my y-axis. So this one ends up right here. So it's now negative 1, 1. 4, 2 becomes negative 4, 2. 9, 3 becomes negative 9, 3. So see how all I did is reflect these across this. So now it's been reflected across my y-axis, and I've done this first step right here. The next thing I'm going to do is stretch vertically by 2. This means I'm multiplying all my y's by 2. So my first point, 0, 0, if I multiply 0 by 2, it still stays 0, so that one doesn't change. My next point, this is negative 1, 1. Your y value is currently 1. If you multiply it by 2, 1 times 2 gives you 2. So my new y value is going to be up here at 2. So I'm stretching it vertically. If you look at your next point, this point is negative 4, 2. Again, your y value is currently 2. If I'm multiplying 2 by 2, that gives me 4. So my new y value is going to be up here at 4. So see how I'm stretching this point vertically? So I'm pulling it up vertically, which is up or down. Finally, this last point, negative 9, 3. So right now your y value is 3. You want to stretch it vertically, so now instead of 3, let's multiply that by 2. 3 times 2 is 6. So this is going to go all the way to 6. So again, see how this has been stretched vertically? I've multiplied this by 2, so it's doubled. And now I'm just going to connect all these because it doesn't need to be shifted at all. And this is my function right here. So one more time, this is my parent function. I first flipped it across the y-axis, and then I multiplied all my y's by 2, so I stretched them all by 2, so that they're now twice as tall as they were before. Okay, again, domain and range. So our domain is our x's. In this case, our leftmost point, so because it's pointing in this direction, we're actually starting at negative infinity this time. And it ends at this point right here, which is at an x value of 0. So always left to right, smaller number to bigger number. Range is our y's, so our starting point is, our lowest point is still this point right here, which is 0. It's still pointing up, so it keeps on going up to infinity. Okay, let's move on to number 3. So for number 3, again, the square root tells us our parent function is 0, 0, 1, 1, 4, 2, 9, 3. So this is my starting point. And let's look at the two transformations that are happening here. So this negative is on the outside. So what is it affecting? Your y's. If it's affecting your y, this is an x-axis reflection. Now the 2 is on the inside. So if it's on the inside, it affects your x's. But remember, whatever is affecting your x is going to be the inverse. So if it's inside of the function, it's going to be the inverse. So instead of multiplying by 2, actually going to multiply by 1/2. So it's an x, so it's horizontal. And because you're having it, it's actually a compression by 1/2. So x-axis reflection, horizontal compression. Okay, so let's start off with flipping it across the x-axis. Here's my x-axis. I'm going to flip all of these points across it. So 0, 0 again stays the same. We're flipping this one across the x-axis. This 4, 2 goes down here to -2. 9, 3 goes down to -3. So I flipped all these points over the x-axis, so they're now below the x-axis. And now I'm going to be compressing horizontally by 1/2. So what this means is I'm going to do half of each of the horizontal distances. So horizontal means left or right, so I'm going to be squishing it in this direction, left or right. So if I take, so 0, 0 doesn't change because when you multiply 0 by anything, it stays 0. This first point, if I squish it, right now it's at 1. If I half that, it's now going to be at 1/2. So it's going to be halfway in between 0 and 1. This one's going to be a little easier to see. If you look at 4, -2, we're compressing it horizontally, which means we're going to be moving it left and right. So right now my x value is 4. If I cut that in half, half of 4 is 2. 2 is going to be my new point right there. So see, I'm squishing it horizontally. It's getting smaller horizontally. Now my next point is 9. So at 9, -3, again I'm squishing it horizontally. So right now my x value is 9 because I multiply my x by 1/2. I'm going to half that. Half of 9 is 4.5. So my new point is going to be about right here. So see how I squished it horizontally? It used to be 9, now it is 4.5. And I'm going to connect all 4 of these points. Still draw an arrow. And now let's look at my domain and range. So domain, leftmost point starts at 0, goes to infinity. Range in this case a little bit different because now the lowest point is actually the arrow. The arrow means it keeps on going down. So it's starting at -infinity, ending at 0. Okay, one last graphing equations. So this one I put on here on purpose because you might get a function that you need to rewrite a little bit. So right now I have the 5 as before the -x. I don't want it to look like this. So let me put the -x first. And then right now the 5 is a +5. However, if you remember from quadratics, if you have two different transformations that are happening to your x, they need to be separated by a parentheses. So what this means is I need this to have a parentheses inside to separate the negative from the 5. So what this means is I'm factoring out a negative from both of these. So if I take a negative out of this x, it becomes +x. If I take a negative out of +5, this actually makes it negative, because a positive divided by a negative gives me a negative. So this is the function that I'm going to be graphing right here. So this is the same thing as this one, we just have to rearrange it a bit so that it looks like what we're used to seeing. So again, square roots, so we're starting at 0, 0, 1, 1, 4, 2, 9, 3. Same parent functions every single time. Let's look at what's happening to this function right here. The negative in this case is on the inside of the square root. If it's inside, it's affecting your x. If it affects your x, it's a reflection across the y-axis. And then we have this -5, which we know is affecting our x as well. but because it's our x's, it's going to be the inverse, so we're going to add instead of subtracting, which means we're moving to the right. So we always multiply before we add or subtract, so we're first going to do the y-axis reflection before we do the shifting right. So first thing, let's reflect across the y-axis. Here is my y-axis right here. So I'm going to reflect it across the y-axis. So 0, 0 stays the same. This one reflects across, is going to be right there. 4, 2 becomes negative 4, 2. 9, 3 becomes negative 9, 3. So see how I reflected this from here across to the other side of my y-axis. And now I'm just going to move each of my points right 5. So I'm taking these points right here and I'm moving them right 5. So this one goes 1, 2, 3, 4, 5 to the right. This one goes 1, 2, 3, 4, 5 to the right. This one goes 1, 2, 3, 4, 5 to the right. And my last point 0, 0 goes 1, 2, 3, 4, 5 to the right. And this is what I'm connecting to form my function. So again, make sure you always do the multiplication before you add or subtract. So you first have to reflect or stretch before you shift. Your last step should be moving it. Okay, domain and range, so let's look at our x's. Leftmost point is an arrow, so negative infinity stops at x-axis, which is at 5. Range, it starts at, our lowest point is right here, which, be careful, my y value for this is not 5. 5 is the x value. My y value is 0, because this is on the y-axis, is at y equals 0. And it keeps on going up forever, so infinity. Great. Okay, so now let's do two different types of problems where we're going to be going the opposite direction from a graph to the equation. So let's start off with number 5. So I'm going to draw my parent function again, because that's what I'm always starting off at. And so 1, 1, 4, 2, 9, 3. We are going to see what's happening here. So first of all, notice it's been flipped across the x-axis. So if it's x-axis reflection, we know that means it's going to be changing the sign of our y's. So if it's been reflected across the x-axis, this is what the function would now look like. So now, once it's reflected across the x-axis, this still does not look exactly like I want it to look, right? It clearly has been stretched. It's been stretched in this direction, which is vertically. So we know it's some type of vertical stretch. Let's see by how much. So before, this is 1. Now, it's at 1, 2, 3 instead of 1. Over here before, this was 2. Now it's 1, 2, 3, 4, 5, 6. Before, this one is at 3, now it's all the way at 9. So notice that all of these have been multiplied by 3. So our y's have been multiplied by 3 to get to the new points. No shifts because it's still starting at 0, 0, so this is all we're writing in our function. So f of x equals, because these are both affecting our y, they're going to both go on the outside. So I have a negative and a 3. They're both going to go on the outside of my function, which is a square root, because look at the shape of it. It's a square root. Nothing else happening, so this is just x. This is my function for number 5. Okay, let's look at number 6. So this one, it's pretty clear to see already that there has been a shift, right? So this is where it's supposed to start. It's supposed to start at 0, 0, but instead it started over there. So let's just write down what this shift is. So it's moved 1, 2, 3, 4. To the right, and also 1, 2, 3, 4, 5, 6 up. So we already know 4 to the right means we're going to do x minus 4. We know it's going to be an x minus 4 because inverse. 6 up means we're going to be plus 6 with our y's. Okay. Now what we're going to do is go up here and pretend that this is our origin. So if this was our origin, what would my function look like? It would look like 1, 1, 1, 2, 3, 4, 1, 2, 4, 2, and this one's even off the graph, so I can't even see it. So clearly something has changed from my original function. This is what the original looks like. So notice that it is going in a different direction. So not only has your x's become negative, but your y's have also become negative. Instead of going 1, 1, it's going negative 1, negative 1. So this is both an x-axis reflection and a y-axis reflection. So your y's have become negative and your x's have become negative. But if you notice over here it goes 1, 1, 1, 2, 3, 4, 1, 2. It still is in the same stretch. I mean, it's the same numbers, so 1, 1, 4, 2, 9, 3. So it hasn't been multiplied by anything, so there's no stretch. It's just been reflected. So this is what we were working with. So f of x equals, y's are on the outside, so there's a negative outside of our square root. Negative inside of our square root as well, because the x's have also become negative. X minus 4, since it's moving 4 to the right, and then a plus 6 is on the outside because that's our y's. This is my function right there, number 6.